is about the optimization of JMeter scripts. And about me, I work in test automation about 7 years. And sorry, 1 second. I deal with backend, embedded systems, and performance system testing. And before testing, I was in system administrations, network administrations in IT department. And I have experience with JMeter, Python, Java, and a little bit Ruby in my latest project. So what I will discuss in this presentation is about what was in our performance testing before I joined the project, and how to improve test development for the JMeter scripts and how to improve their maintenance. And this touches fragments and CLI parameters. So how and why we can use and extract API requests from UI pages, and why we can simulate this API request for improvement of our development. What if we can record API calls from UI pages with browser before test, and how it can help us in like maintenance of our tests later. Examples how we configure performance logging for WebDriver in Java, and examples of the CSV file structure we can use to replace these recorded logs in JMX scripts. Why we can use and for what we can use performance logging in functional testing. So about initial state of performance testing on the project, we had a lot of different implemented things like performance framework, performance reporting portal where we see data, and it has many measurements after tests, like historical data we can analyze and compare how it was previously. But performance test scripts were all in one approach. So JMeter script was long, big, and not easy to understand. And besides that, we had functional test in Java. So it is a lot of experience in the code in Java we can reuse for our performance testing. So why do we want this change? Because for me, it was particularly my case, for me, it was hard to read and to maintain log existing JMeter scripts. I spent hours and hours trying to understand why is this here, what is it? I saw this in other place, is it same or it is somehow different? So it was really too much effort to update such test cases, especially when it was a new API used in our UI pages or some new API implemented in new pages, and we need to add this to existing scripts. We not protected from calling old APIs. So it was many cases when we run performance test, we reported the performance issue, and then developers investigated to tell us, sorry guys, it was already changed that we don't use this API calls with these parameters anymore. So we need to re-implement test and rerun it with new. It was really hard to debug issues in one monolithic JMeter script. So when it fails, sometimes you cannot understand which iteration, which loop, and why it fails, because of what parameters. It was not enough logging. And it is really, how to say, unpractical to do thorough logging when you run performance JMeter script. You have no time to do a lot of logins. You just need to collect metrics and that's it. If you run in like several thousand of parallel threads, it will produce gigabytes of log data. So it's better to debug and investigate in parts in separate, small, like mock environment. Yeah, and one more, it is really inconvenient to do review for updates in JMX files because it is XML. And when you commit new changes, you see a lot of, let's say, noise in the PR. So you rely on what you see as a result of test execution, or you need to open the test in IDE and check what you actually have in the script with UI tool. And there is no tools to emphasize where is our change. So you need to know this script before change and understand how it will work compared to what was previously to what implemented right now. So our goal is implement test which will be easy to read and maintain. And we should use code reuse. So we don't repeat and implement same things which is already implemented in previous tests. We don't want to update API calls manually, and we don't afraid to use outdated API calls in performance tests. So we can use same script without local modifications for any environment. Like you develop your test script locally, you can run during development of the script against dev environment, or you test staging or separate like prod environment if you're doing actual testing. And for our own like needs, it would be good to use mock server so we can run even and implement tests even without actual environment, so we can implement same time we wait for developers implemented these APIs or features. So we're going to use reusable blocks and store API endpoints and parameters in CSV file. We would like to generate CSV in automation, but this part is just not covered how we generate in automation, particularly, mostly in general. And we have CLI parameters. We can change some part of the test script from command line. So general principles to keep in mind in this performance testing is, as in all software development and testing development, is try to not repeat yourself. So it was first principle violated in big scripts. It was many times repeated fragments. In each script, we have the same fragment hard-coded and copy-pasted. So we would like to avoid of repeating parts, and it is also synonym for this principle is single source of truth. We have to find where the original data come from and use this original data, not copy-paste this. Keep it simple principle, so it should be easy to read, easy to understand, because from software development experience, we should know that when you write code, you write it once, but many people, and including you, will read this code many times for maintenance and support and to understand what it does as documentation. So because of this, the better and easier to read this code, the more time we can avoid spending for nothing. Yagni principle is you are not going to need it. It is principle to avoid some complicated things you not need in the future. Maybe you think you will need, but practically you maybe not need it. So just implement what we need right now and do not make too complicated things. And in object-oriented design, it is also a very important principle to use. It is solid. It is single responsibility, open close principle, Liskov substitution principle, and interface segregation principle, and dependency injection principle. So these all principles we're not going to discuss in this presentation, but it is good to know if you work in performance testing, you may become not from the test automation, from manual testing. And if you develop some test scripts, you need to learn about the principles and apply it to these scripts. So what we mean by breaking the scripts to fragments. In JMeter, we have a special, it is grade menu in the tree, and it is not used for test execution. It's like a special place to keep fragments we don't use, and we can include these fragments to our actual code. So if we are going to implement test fragments, we put it under this menu, test fragments, and create separate block of code or samplers which work together and covering one particular goal. For example, I can break test script to 3 small steps like log in or make authorization, and then measure this API call, and then log out, for example. So these 3 fragments should be implemented separately. So next time you implement one more test for performance testing, you just include existing fragments for authorization if you're working with the same application. And you don't need to copy paste it, because if you need to change something in the authorization process, you just go and edit test fragment, and it will be included with all these modifications next time you open the test. And in this case, you don't need to modify several test cases after one change in authorization. So after we implemented test fragment, we include this test fragment via same menu test fragment to the main part of the test. This, like above, it is main test. And in test fragment, we use include controller. And include controller, we make link to the path where we have previous small fragment. So in this case, we can include many fragments we need for this test case above. And then we need to use this fragment in the main script like this. So in the test code, in testing thread, we use module controller. We give it a name what we need, and then we select here. We have like menu to select one item, and on the right with number 4 step, we have list of all fragments included in the bottom part of test fragments, all test fragments. So you just make link and select one fragment you would like to use on this step. And then during test execution, you will have this fragment executed. So I can show this with example.
Yes, please. Yeah, we can see.
This is one test script, not actual production test script. It is implementation of the test step here, where we include module controller, and in the bottom part we have 2 fragments available for us. So one of these fragments is selected here. So like if we select first one, we will run first one. If we select this one, so we will be executing this step in our test. And in the above and below part, I use just mock server wrappers. So I create expectations in mock server, and then I can use this in my steps for CSV file. So if we execute this, we can see results in view results tree. So I will describe a little bit better about what we're doing in this part, but actually it was prepared mock server API expectations, and then we executed actual fragment from here, and we can see what is in the fragment. It is this part implemented only in test fragment sub tree. It verifies some project related parts, like if you have API token available for making authorized API calls and header manager configured like this, then you run in the loop several steps. So this part related to only one measurement. It is iteration between API calls collected to CSV file, and from this CSV file we read with bin shell script. So this is not embedded to the JMeter. It is implemented for support this approach we will discuss, but it helps to reduce implementation of many different steps in JMeter, and like record what you can or collect all you can to CSV file and the replay from this file. So I'm going to be back in the slides. So how we collected and decided what data we need to put to the CSV file for such execution. It is an example of dev tools in the Chrome browser, where we see get requests to API endpoints from some website. And in this example, I'm trying to show that we have most of the calls are get, and it means that we can repeat these calls many times with same parameters, for example. So if we collect these calls during actual execution of functional test to CSV file, then we can reuse these calls for performance testing. With post requests, it is completely different situation. If you post one request, you very often cannot do the same request to a same result. So you need to change this and implement test fragments for post request manually, depending on your situation. So this part is out of the scope of what we discuss in this test, in these slides. This particular fragment was implemented for performance testing, which simulate behavior of UI pages of particular application, web application. So what is part of this? It is we need to simulate API calls we usually have during this UI page opened. And we would like to reproduce the situations as all these APIs called in parallel at same time, because in the front-end application, you not call one API call after another, you call this all at same time. And because of this, we need to use parallel HTTP requests, which will be triggered once at the same time. So this is example how I organized and how I propose you to think for organization API calls in CSV file. And this is structure in example. So page one, it is, let's say, home page. And in this home page, we have two API calls. So this number on second column, it is representing kind of steps for performance test fragment. So we pick up all these fragments with ones in second column and execute them all in parallel. And then we execute all API calls with 2 and execute them all in parallel. And in this way, if we have 10 calls for page 1, we will simulate 10 calls in parallel for first iteration, and then in second iteration, all calls for page 2. And how we can collect these calls, it is automation approach. It is ideal. If you can use manual approach as well. You can collect API calls yourself. So you will keep set of API calls in one place. It will be a clean CSV file. You can easily compare with previous versions when you doing PR and update this API calls to some new versions. So this is also possible to keep them and update manually. So it was about the same demo as we ran already. So I just can explain a bit more. So see here, we have page 1. The page 1 name of the UI page was on the first column of our CSV file. And then for 2 API calls, we have this under this page 1. So it is it shows us that we get page 1 and in parallel executed like 2 separate API calls, same time, started about the same time. And then we iterate for each line in the CSV file and execute page 1, page 2, and then again page 1, but API call is a bit different. It is other API calls from next lines, not the same. So we can simulate even same page, but with different recorded API calls from different UI pages. So it means you can, if you can execute functional test like several times with several different parameters, like different users or different navigations, you can record this and then replay in performance testing. And in this case, you need less implementations in the JMeter script and more collaborations with functional testing teams. And it leads to smaller performance testing scripts and less maintenance time. And no duplicated efforts because you not re-implement same API calls in JMeter, which was already implemented in functional testing. I will back to presentation. So this is what we already saw. Maybe not this part, but we see on the right that we called this API call with this IP address, this port, and this endpoints with all parameters. So we're sure we can check what was called. And now we can decide how we collect API endpoints from our application. So one of approach is using DevTools. We can record these API calls and save to HAR files. It will have almost all info we need for this and other debugging activities. We can use proxy server, mock-in proxy server between your functional tests and your environment. So you can record API calls, parameters used for these calls, and then collect these to CSV files. One more approach is collect API calls and parameters with browser logs when we enable performance logging capability in the Chrome browser. I will use examples with this approach because it was like best suit for our existing test framework and functional framework what we had. It was recommended that there is one more approach to use Chrome Net Export tool, which can also collect all external calls to websites, API calls from your UI application. And it looks to me there is new Selenium for bidirectional API and good support for DevTools protocol, Chrome Tool DevTools protocol. And it should be this almost the same as performance logging in ability to provide this information, but hopefully with better support from API, because in performance logging, you need to parse logs almost manually yourself. So if you research this, start maybe from Selenium, mock server, Chrome Net Export, and if this cannot work for you, then check performance logging. So what is performance logging? It is like maybe some pre steps how Chrome DevTool protocols was implemented and what data it relies on. So this was one presentation from Michael Klopikov, and this is links to his pages and its presentation. So it is more detailed about the performance logging, but in several words, it is additional logging in the browser. You need to add couple lines in setup of the browser when you create new driver. So this is before change. We have set property for pass to the driver. And after this change, you have these lines added to your existing code, like we create login preferences and add log level alls and set this capability. So after we enable this, we can collect all API calls during functional test runs to browser log. And to get this data from your functional tests, you need to get WebDriver logs. You need to get log type performance. And you, if you're interested, you request all log levels. So after you get all these logs, you filter, you may need to filter some because it will be like thousands of different activities, including UI, navigation, visualization parts. And we need to pick up network request will be sent, which has all API data we may need. So I will show some not related to my production example. It is a test framework from one of my colleagues. It will run test. It is same approach how we enable performance logging here, as I show you in demo. And then after test execution, we collect available logs and parse and print these logs to system out println. So if we run this test, it will start browser. It will actually fail to log into application, but we don't need to wait until any activities on the pages. We just would like to see that after test executed and we collected logs, we filtered, network request will be sent information, and we can find API calls, all data used for this. So we have URL, we have timestamps and other information we may need to use for us. So it is just more targeted information from these performance logs. So you can get what method was used, what URL you use in this call, and you have in Java, you have many other languages, libraries, which can parse full URL and extract separate parameters and values. And also we have request ID, timestamp. We can measure time we spent in our browser for each API call with these timestamps, so we can create some baseline about the performance of our application even without separate performance test. We see whole time, and from these many API calls, we can find which page, which API calls comes from when we trying to split which API call was from which part of our application. We may want to look to referer headers. So this API call in URL, it is come from page boards. So next API calls, if they related to other UI pages, you can find from what pages they come if you look to the field referer. So it can help you split separate pages in the CSV file. So with provided examples, we can capture latest API used in the UI pages and filter these APIs. We don't want to put post requests. We would like to filter and get method only, collect in CSV file, and then we can reuse this for performance testing. We can collect performance statistic directly with these log files because we have timestamps, so we can find which APIs responded slowly, which was most slowest, and we can collect baseline to compare with performance test. And what I found for myself useful is when we use this performance logging and print this information in our test logs, it really helped me to analyze failures in the functional tests because I see what API calls was finished with not 200 response codes and what errors or issues we had during the test execution. So we almost done. This project was like implementation was a bit not shared here. For each separate project, you have different methods, different frameworks, different languages. So this part could be completely different from what you have. And you can, like, if you have option to wait and to run functional tests like several times, 100 times, you just collect all parameters and then reuse. In case you cannot do this, or you collect API calls on one environment and going to execute this over another environment, you can change API parameters in the CSV file to something you generate programmatically, so it will be different from collected in functional tests. In my case, we had many big JMeter scripts before this implementation, and after we mostly relied on collected API calls, so it was no big tests implemented after this available for the team. It was mostly recording new UI pages automatically and rerunning almost the same JMeter script with just freshly generated CSV files. So we like switched a bit from implementation in JMeter, less and more in implementation of functional test part in Java. So we can decrease maintenance of JMeter files really in huge amount. So our test script decreased and readability improved because it is just couple fragments, and we have each separate file for separate functional part of the test. We really decrease time to implement our new test because in most cases we reuse all available fragments, and if we need something new, we just implement one fragment. And we always have latest API during our performance test executions. And same time, we still need to support and maintain and implement post request out of this approach because it is not supported. If you need to implement some complex requests like async calls, it is also cannot be captured automatically, and we need to implement this ourselves in separate fragments. These examples available in repo, and my Telegram for this talk is available in this link. It's called JMeter perflogging. And thank you. We can switch to questions. I can show and run and answer the questions. I little bit skip part about the reusable parameters. I will tell about this when we in JMeter one more. What questions do we have?
Okay, first of all, thank you very much for coming, for joining, because I know that early morning in your time zone, so I really appreciate you could present this topic. And let's see what we have in the questions. Juber is asking, wait a second, how to exclude Ajax calls. I didn't get personally the question. Maybe you can elaborate and just unmute yourself and ask, what do you mean? Why do you need to exclude these calls from test fragment plan? Exclude Ajax calls from test fragment plan.
So who asked this question? Can you be more specific if possible?
Yeah, hi Max. I'm audible now.
Hello,
Yeah.
yes, I can hear you.
Yeah, hi Max. So actually, I did not understand the test fragment like what you explained in the beginning. So there, like you have added like the calls and mainly like services calls into that CSV file, and from there, like, so does it mean like we need to have all the calls included in that CSV file, or like how? Because for the Ajax calls, like there could be like many calls, like in real time application. I'm like saying there could be like many Ajax calls, and sometimes we don't like include all the Ajax calls, like whatever it is happening in the application into the test plan.
Yeah,
So do we
yeah.
need like all the time? Do we need to like, because there could be like hundreds of the Ajax calls are happening on the client side. So how we
Yeah.
can like handle such situation?
Yes, exactly. It is a good question. And this is part, in my case, was covered in actual project, was covered in the functional test part. So when I collect API calls from this performance login API, like this, right? So you receiving logs from your application with all API calls happened during the UI application running. And then, of course, you need to exclude some of them. So you probably want to exclude post requests because you cannot replace them again many times. I excluded, first of all, I excluded API calls related to authorization. So we did our authorization in separate fragment, and it was already implemented in the JMeter. So we don't need to record this and replay. So it is just your decision and your logic. You can exclude this API calls by domain, by method, but even API endpoint you want and don't want to measure. There are different Google APIs for collecting statistics. There are different APIs for enable, disable some features in your UI application. So of course you exclude this part, but you exclude this not in JMeter. You don't want to make complicated JMeter script because all these changes hard to review and hard to find in JMeter. It's better do this part when you filter API calls collected in performance logging, for example. Same way you can collect this API calls with mock server, or sorry, with proxy server. So you start your application. Before creating driver, you create mock server, provide parameters to the driver, and then after execution of the test, you collect data from mock server, what API calls was used, and then you filter all you don't want, like all third-party domain names you don't need measure, you don't need to exercise, which is not from your implementation part where you need to do performance measurement. It is good to filter because we don't want to spend time and we don't want to exercise something not under our control.
Just funny part,
Yeah,
you can
thank you.
apply this approach for making DDoS to your like separate company that you are competing with.
Yeah, if you not exclude this, right, you will be doing DDoS.
Thank you. So next question, Shashank is commenting that reusability is a bit of challenge when you are using JMeter. Did you consider just switching to another tool? What are the considerations when you decided to continue this like JMeter implementation? Because you mentioned that you spent a lot of time actually digging inside this monolithic script. So maybe it was like more feasible to switch the tool. What do you think?
So what was in my case, it was several big tests implemented in monolithic approach. So we stopped to implement this new monolithic scripts with approach where we reuse test fragments. And actually, we even almost stopped to implement something new in JMeter because this approach was quite universal. You don't need to change almost anything after you have like in JMeter, you have authorization fragment, you have this CSV replay fragment to re-execute, to replay collected API calls, and then you have logout, for example, or some finalization fragment. Only part we need to implement after this, it was part where we do API, async API calls. So for each async API calls in the application, we need to implement separate fragment with different endpoints. And that's it, what we implemented in JMeter. After this, we just use programmatic approach. We call all our performance tests from generated data in the functional tests. And because of this, for us, like there were no more challenge with supporting JMeter scripts, at least with new tests. Only like challenge was maintain old big files. We don't want to touch and re-implement everything from the scratch. So it was only approach when we have new API calls or changed API calls parameters for this big implemented tests. We just extract this part to separate fragment and reuse this fragment in all monolithic scripts we have. And after we investigated actually other ways what we can use, like K9 framework, but it was not successful in our case because with JMeter you have very easy tool. You can play and try something very fast yourself. Just click mouse and do small tests. And this is much more convenient from experience of our team. So we still like this approach to use JMeter. UI is quite good. You can see and navigate and check log files and everything like this. But when you run tests, you don't run in UI, you run from command line. So it was part in my presentation with parameters. Let me find this so I share it again because I didn't.
Yeah, thank you for answering.
Explain this.
And I have a follow-up question for this. Can you describe just maybe in more details how did you deal with this legacy JMeter script? Did you try to extract logic from it in your new modularized test, or how did you kill this beast? Just I'm interested to know.
So for legacy existing tests, we try to don't touch this and rewrite from the scratch because it was really big. And why we don't want to touch and update the scripts? It is history of available. It is like set of available historical data. We can compare results after we execute performance test. We look into all previous executions and compare where we right now. And if we completely re-implement the script, we have no such good baseline stable for like several iterations. We need to start from the scratch. So if some big changes were in application between the switching, we just don't want to lose this control of our history, where we can see our historical data. So because of this, we decided to keep all as it is. And if we need to change some APIs in the script, we just re-implement with separate fragment, include this fragment in all. So these all big test scripts were almost about the same. So they have like hundreds of API calls, and all these hundreds, like maybe 10% of the 100 was a little bit different, but most of them were the same. So because of this, we extracted one fragment and include this into all these legacy scripts and then run this as previously. So I'm not sure if I answered your question, but if not clear something, I can explain again.
Duber is asking if it's convenient for you, maybe you can copy paste these two GitHub repos that you mentioned in your presentation with examples.
Yes, of course. Yes, 1 second. I will just finish this CLI parameters.
Okay.
So again, in this big script legacy scripts examples, it was several sets of the scripts, like one set prepared to run for dev environment against dev environment, and same script with little modifications to run against QA environment. And this part actually can be improved with CLI parameters. And on the right side in the green, it is example how we can read CLI parameters in the JMeter script. So this like threads name of parameter, and after comma, this default value we use in the script if no parameters provided from command line. And on the top, you see this how you usually call JMeter script for actual measurement. It is from the CLI. You don't need UI part. It eats some of your resources and affects your measurement. So high load performance test you run from CLI, and you can call JMeter -s-t case test script, and -l is results where you collect JMeter logs. And in between, after JMeter with -d, you can pass any parameters, any names you can invent for your application. Like, for example, threads equals 2. So this syntax will go to the parsed parameter threads in the thread properties, and this one value will be changed to what you provided in CLI. So in this case, you can control different levels of load, what you need in your test. You can control like prefix, suffix, or URL of your API or of your application if you would like to switch between local dev QA and staged environment. And this is like almost one of the important part of the improvement. You don't need to have 2, 3 different sets of the same scripts for different environment. If you don't use parameters, try yourself, you will like it.
Okay, thank you very much. I have few more questions. You mentioned that you used JMeter for authentication of users. Can you elaborate how it was implemented? What was the source of credentials? Do you use CSV or how?
No, it was not CSV, actually. It was just sorry, cannot find Zoom. How to switch? I need to stop sharing screen maybe.
Yeah, you stopped sharing.
So we use test fragment. This test fragment was implemented like fully manually. So we collected like as a CSV file. Yes, it was as a CSV file with let's say users and passwords, username and password. And in each thread before execution performance test, fragment was to authorize this user, then execute several API calls, and then other fragment did logout, so this user exit. So next thread which pick up this username from CSV file can authorize again and complete full set of operations.
Got it, got it.
One more approach, sorry. One more approach we used in some of the test cases for performance test. If we need just not simulate UI, we don't need to simulate user behavior. We just need to measure some particular API endpoint. We run functional test, make authorization for the user, and store a JWT token locally in local file, and then just open this file and use this JWT token as parameter of existing test fragments. So all fragments reuse same authorization, for example, or also set of authorizations in CSV file, but already like pre-authorized JWT token.
So if I correctly understood your approach, you basically use JMeter mainly as just fire a gun for the requests, and the first step would be login, get some token, and then you don't care what kind of logic will be executed because you basically just make a file with all the requests it should run, and JMeter doesn't know any business logic. It just fire the requests.
Yes, exactly. It was like main idea for reusability and like make use of existing functional framework. So after we find what we need to measure, we ask if it is implemented, all such steps implemented in the functional framework. So we have options to navigate to this page to select this control and click this button and do like workflow for user. So we just implement almost the same test in functional test framework. We navigate this page, this page, this page, select this option and filter these actions and this and this. And then we repeat this in cycle. So we repeat this multiple times, maybe for different users. Maybe one user have to navigate like one option, second option, third options to navigate through all part of this particular application. And then we record all these calls. And then JMeter was almost like I shared on the screen. It's just 3 fragments, authorization, execute CSV API calls, and log out. And this logic was not re-implemented or duplicated in JMeter script. It's just a little bit tuned functional test where we record this. And you don't need to from one side, if you would like to collect hundreds and hundreds, maybe 100,000 of API calls, you also need to optimize your functional test to make it in parallel. But in cases when you depends on the capability of your application. If you support 1,000 and 1,000 users, it could be also challenging. So you don't need to do this 1,000th time in functional tests. It will spend hours and hours for you. So in this case, you just capture maybe 1, 2, 3 times, and then you change parameters, user ID or something, what you have in your application programmatically, and then have this big CSV file and replay it. If your application support like not 1,000, but 100 users, you can execute this 100 times, collect without generating these users in the script, and then just replay what you recorded. So it depends on the performance. So it was in almost all cases, in 90% of cases, we just recorded several iterations and replay them from multiple users. And in several cases where we need to generate tons of data in database, we have to write optimized multi-thread Java application to generate this database data and then run performance tests. So it's mostly focus moved from the JMeter to functional tests where we all logic implemented in functional tests and just measurement in the JMeter.
By mentioning database, you mean that you need some preparation before execution of JMeter?
Yes, of course. If you test, you can have different tests for performance measurement. So one of them is how many users can exercise your API. Other concern is how your performance slow down because of data growth in database. So in such cases, we need to generate, let's say, 1,000 records in database and then execute performance measurement. Then iterate and run functional test and generate 1 more 1,000 records in database, and then again do performance test. So in this case, you may need some good optimizations and thread safe coding in functional tests so you can generate this data faster and don't wait hours. So in this case, it could be like you run for hour data generation in functional tests and then 10 minutes of performance test execution. And to see the trend, you need to do this several times. So it could be too long.
Speaking about the trends, you mentioned that you use some historic results to compare as a baseline. Do you use some kind of third-party tool to visualize these JMeter results, or what it was?
It was to customize our in-house solution, so I cannot explain and recommend how to use it because it is not available. But I can recommend to look into time-based databases. So also very good approach to collect data. but I cannot compare and say which is better, which is not better.
But maybe you have in mind some open source solution that can be used for the same approach.
Yeah, I cannot say names right now. Of course, you can use any open source time-based databases, and only I can recommend is what you need to decide for your particular needs, because in many cases it was recommended like one solution, but this one solution was not able to do injection of all data to the database. So it's basically you inject data and like timestamp generated when you inject this data, for example. And we need solution where we can just get all our previous results and re-inject to existing database. So historically back way. So in this case, we cannot like use what is recommended by all experts for open source solution. We need to pick up our solution, which like good for our needs. So it really depends of specific cases. Some of them good for you and some of them not good for you. So it's like only depending on the projects.
Okay, sounds good. Thank you very much. I'd like again to ask, maybe someone wants to ask more questions, please just put a message in the chat or just unmute yourself. We are here to discuss, so don't hesitate just to shout your question.
I can read one question, maybe we not discuss it, from Lyubov. It is about the if JMeter supported only by Java or other programming languages also integrated. It is, as I understand, could be two different questions. One is if what I show in code implementation for iteration on CSV script part, this part is using bin shell sampler, which execute like kind of Java language, but it is like optimized Java. And they support 2-3 different scripting languages. And bin shell Java was like not fast enough. It is not the best solution for big load levels, but it is similar to Java, so was good for me. There are other scripting languages you can implement internal, like internal parsing of some data or preparation some data in JMeter. And if it is related to how we run JMeter scripts from Java, it is not related to Java support at all. So we just call CLI execution, like system execution of any files you can execute. So this option available in Java, this option available in Python, in Ruby, in all languages you can call some.
Maybe you can expand this question to answer like what kind of executor, I mean virtual machine, or what do you use to run this JMeter CLI command?
To run JMeter CLI command, we use our Java framework. So it was called from Java, and just wait. So why it was in Java? Because as I told previously, in most cases, we need to like do iteration between Java and JMeter. So it was no sense to exit from Java application and then start it again. So we still remain in Java application. We execute like functional part to generate some data. And then we execute CLI call for JMeter, executed measurement, wait. And then we execute second iteration when we like have more users or more records in database or what we measure in this case. And because of this, we call this from Java most of the time. But the parts of framework was in Ruby, we called from Ruby. So this is
I mean, it was like a separated machine with a lot of memory, CPU to run these tests, or you can just execute them as usual functional tests in your CI/CD?
Yes, it is very good question because it is not on the same machines where we execute our functional tests. Of course, functional tests executed on lightweight machines where you don't have a lot of memory, they are executed for like one set of UI application in the memory, and that's all. For performance testing, we need more high-performing machine. It was really big servers with hundreds of gigabytes of memory.
So you used bare metal to run it?
We used bare metal, yes, because it is like, in general, several approaches where you run small application, like less instances, for example, right, for performance measurement. And then you kind of expect that your production application will work like 10 times faster because you have 10
like
times.
Extrapolate. If
Yes.
one instance works like that, we expect that 10 instances will give you some kind of this.
Yeah, it is one way of execution of performance test in like this. And with this approach, you maybe don't need bare metal high hardware on the machines. And we used other approach. We had like realistic environment. We was able to run and create dynamically on demand with on-demand approach any production-like environment with like this amount of database and memories and instances, or middle level or high level for big customers. So we was able to measure this with realistic approach. So because of this, we need hardware bare metal servers with 100 gigabytes of memory.
By the way, I'm interested, did you fire these tests against production?
We had this tool called we can control and create fully same production environment, like, so the same script to generate customer environment and same script to generate as environment, just different parameters, right? So we just create QA1, QA2, for example, prefix, and then it was created fully same, like same cloud, same parameters, same machines, same memory, same database.
Basically, you replicated completely the setup from production.
Yes, we were able to completely replicate for performance testing only this level of environment as for customers. And then we need to generate same amount of data as customers has in their environment. It was, of course, not 100% similar, but it is like about
good
the
enough.
same. So
good enough.
We know that customers like have 1,000 lines of this in database and hundreds of thousands of this data in this database. So the shape of the data maybe not same, but the count of the records was about the same. So we was relying on our measurement as on customers' databases.
And last one question from me, sorry. Imagine that you still like thinking how you can improve this approach. You are fine with current like implementation, but what steps you may think of can be improved further?
Yes, it is also interesting question, because what was not optimal after all these solutions were implemented, it is when we need to stop performance testing. So it is very good talk on the YouTube about how to not measure latency, And this is talk about in most performance tests, in most benchmarking tools, you load your system too much, it is like car crashed to the pole, and it's already everybody dead in this car, and you measure how they dead, how it behaves, and like how dangerous
how badly are injured processes.
Yeah, so this is like not correct approach, because measuring like how all services died and what errors they triggered when they died, it is not what you want. You want to just find the first level when we have small slowdown, and we need to investigate where we have this slowdown first and fix if we can, if we have time, optimization.
To find the first bottleneck.
First bottleneck, yeah. You don't want to see when you have like all services throw exceptions to you. It is when everybody is dead in the car. You just need to see if it is already can lead to the accident and use your VCS system to avoid this accident. So this is like can also speed up your testing, because you don't need to wait hours until you reach the crashed car. You just need 20-30 minutes or maybe less to reach the case when you see some resources is bottleneck, and you optimize, fix this, and then you work next and optimize next bottleneck. So this is faster. Maybe it is harder and more
if you
challenging
can
for
share the link to this YouTube, would be great also.
Not sure I can find it fast enough. Let me check.
I mean, it doesn't matter. You can later on just ping me. I'll put it in the description of the recording. So don't be in a rush. I believe we asked all questions. Thank you very much for the valuable discussion. Thank you for coming in on the meetup on Saturday. We have like weekend, but we spent time here. So I really like thankful for all people who came today.